Okay, this is my presentation on bootable containers. Starting last year, back in around November, I got a new laptop and started getting back into Linux again. And I discovered a project called Fedora Silverblue, and it's supposed to be like a mutable operating system, which then led me into another project called Bluefin, which is built on this idea of bootable containers. So let's dive in. What are bootable containers? Bootable container is an OCI image, so either a Podman container, a Docker container, some kind of container that's running in a Kubernetes cluster, and we just add a Linux kernel into that image, and then this container becomes bootable because it has a kernel in it. So there's some other wrapping that has a bootloader and puts the files in the right spot so that your computer knows what to do with these files and boot into the operating system. And so it's not running the container as is, it's actually dumping the contents of that container onto your disk. And why is this cool? I think it's very cool. So for a long time, there's been a lot of tooling that's come out to deal with host operating systems, starting with not just running bash scripts, doing things over secure shell, SSH, and then evolved into using stuff like Chef, Puppet, and Ansible. Ansible's still used a whole lot. I mean, Puppet and Chef are too, but they have some pretty glaring issues, which is it's easy for, if you have hundreds of computers, for one of them to get slightly misconfigured and then continue to be misconfigured. And that's a term called configuration drift. And there's no easy way to get things back on track without just reinstalling the entire operating system. But for the last 12 years, since around 2012, around then, Docker's come on the scene, and then Kubernetes came on the scene, which makes packaging applications very straightforward. You just compose an application from a Docker file, and then you deploy it. But what the container gets deployed on is a host operating system. So we've had this huge revolution in application containers, where any, Git DevOps is just kind of built on top of this foundation where anyone can just build an application, deploy it to some kind of Linux environment, a known environment that they know it's going to work. There's all this tooling that's come around to serve those application containers, to scan those application containers for vulnerabilities, to even run VMs inside of application containers. So everybody in these tech organizations understands Docker containers. They understand, software build materials. They understand registries. They understand tags. But the host OS, there's been some, most of the people running containers are running Kubernetes clusters. Red Hat uses OpenShift, which uses OS tree to manage their, what's called Core OS, it used to be. And Microsoft has their Flat Car Linux project. Both came out of this Core OS thing. And then Talos Linux is doing really cool stuff in having pretty relatively immutable host operating system. But the tooling isn't the same as the tooling for the application container. So bootc really just says, let's take the tooling that we're using to make application containers and make the host OS into a container itself. And so you can run the same tooling, run it all in a Git repository through CI, have vulnerability scanning, the same is happening for the applications as is happening for the host operating system. And so your entire stack is kind of using the same tooling. And developers, finance, auditors, cybersecurity, they'll all understand your entire stack because it's all just Docker files, container files. Last fall, Red Hat donated Podman which is their container engine, and bootc to the Cloud Native Computing Foundation. That meant that they kind of needed to prove that bootc could become like a vendor neutral tool. But because of its dependency on OS tree, there really isn't many uses of OS tree out in the wild. I mean, Flatpak, Red Hat flavored stuff like Fedora and Flatcar Linux use OS tree, but it's pretty esoteric, pretty hard to pull off. And so this led to this alternative backend based on ComposeFS. So ComposeFS uses what's called FSVerity, which is a feature of the Linux kernel that turns the entire root operating system into a Merkle tree. Merkle tree is very similar to how Git repositories are handled. And so each tree, branch of the tree has a SHA sum of some kind, a checksum of some kind, and that goes all the way up so that there's a root hash for the entire OS. And so then what should be read-only is ensured to be read-only from the kernel level. And this means some cool stuff. You can sign the file system with the same key that the kernel signed with the same key that the BIOS secure boot is signed with, so that you have an entire boot chain that is signed. And so if one thing goes off, it'll refuse to boot or give some kind of warning. And it also means that it enables non-OS tree Linux distributions to become bootable containers. So things like Arch, Debian, SteamOS would do all in the last month. People have kind of made some proof of concepts building on these. And so you can go ahead and try to play with it yourself and make your own bootable OS. And what does this mean in practice? I can show you my kind of side project I've been working on called TuneOS. You have a container file, and it comes from this base image. The base images are determined in a different file. So I can pull down Alma Linux or CentOS or Fedora or anything, and then run these scripts on top of it. So, I run a series of scripts. They're just bash scripts. So if you look in here, I'm installing the packages that are needed on top of the base image. It's just a very minimal image. So I'm installing the GNOME desktop environment, some multimedia codecs, other tools, systemd. And I can even just run, install RPMs that aren't meant for this operating system, just install it manually, and install stuff from a custom repository, clean things up, change things around, and it just makes a clean end product. So I can do any customization I want to on this side, but then the person just using this operating system doesn't need to know about any of it. They just have an operating system that works. And why do I say that it just works? If I go to here in my root, everything that's writable for the most part is in /var. So /var is the only mutable part of my OS, and /etc is also mutable. But things like /user and /run, I can't actually write to. So if I go to /user and I try to make a directory called test, can't, read-only file system. Many operating systems, install their packages to /user, and they install their packages to /run. They install packages to /opt, and it kind of makes a mess. Many times I've installed Linux on my computer, my desktop computer. I want to test something out. I install some script I see online. I end up breaking my entire operating system. This way, I can't even do that. It's like getting training wheels on a bicycle. I'm not even allowed to do anything that would break my OS. I can break some stuff by going into /etc and, let's see. messing with my machine ID, I guess. This might break some stuff. Actually, I have to do it as sudo then machine ID. Yeah. So, I mean, I'm not going to do that. And also leads to some limitations, right? I can't just install packages. If I wanted to install, rip grep, it's not going to let me. But there's also some interesting workarounds or adaptations where I can actually use this /-- transient to temporarily install a package just to test it out. And if I actually want to permanently install it, I could add it into my build pipeline so that it's part of the image and it gets distributed out as part of the standard image. So you can imagine at your university, if you had a computer lab and you wanted to use some software temporarily, you could install it in this transient mode. And if it works out and you really need it, then you would just ask your system administrator to add it to the computer lab image. I think the internet's not going to let me install anything, so you just have to believe me. So yeah, what does it mean with the Linux desktop? I already kind of touched this briefly, but these are the most popular end user operating systems, not servers, but phones and computers. You got Android, you got Chrome OS, you got iOS, you got Mac OS, you got Windows, and Linux is about 5%. These take up 95%. We're just going to ignore Windows and that for now and just look at the other four. What do they have in common? Well, they have sandboxed apps. When you install an Android application and uninstall it, it doesn't leave stuff behind. When you install a new update, it doesn't half apply. They have read-only root file systems. You have to root your Android phone to the system file or jailbreak your iPhone. Chrome OS, is a very minimal operating system, and you don't have root access by default. And Mac OS, you have to turn off system verification and in order to actually mess with the system files. They have what's called AB boot. iOS and Mac OS is a little bit different, but Android and Chrome OS, basically they'll have a slot A and a slot B, and it'll install an update to slot A, and if it doesn't work out, if there's some sort of failure to start, it'll automatically switch over to slot B. And so your system OS and your personal files are in separate partitions. And so then the system OS, you can have just 2 copies of it. And when you have an update that doesn't work, it'll just automatically flip back over. And so you don't have a broken phone. That's the vendors always, you don't have a broken phone. And it'll just wait till the next update to try again. You might, you just switch from slot A to slot B, you wouldn't even know. The other thing is image-based updates. Unlike Windows, you ever been on Windows where you have updates going on for an hour, 2 hours, then it fails and it all just goes back to 0. And the same thing can happen, but it's what's called an atomic operation. It either happens or it doesn't happen. It can't just half happen. So you either update or you don't update. You don't have a half applied update. And so all of these are what makes these operating systems, people say they just work or they work well, or they're very simple to use because of these training wheels, these protections. And so let's just bring them to the Linux desktop. And that's what bootc enables. And so this is a project I've been working on called Bluefin. It's very dinosaur themed. It's intended to be a cloud native desktop experience with the center on, containers. supposed to be like a Chromebook. I don't know how many of you use Chromebooks, but Chromebooks are great. They start up in less than 10 seconds. The battery lasts a long time. It just runs a browser. There's barely any other apps you could possibly run on it. But it works great for 95% of people who use a computer who just need a browser, maybe some Word edit, Google Docs or something. And so why don't, just make Linux act that way? And so for people who, like us, who want to do development on it, you can use things like dev containers, dev pod. We can take a look here. So this part of the operating system, we have a Docker container, a Fedora image in this case, running built on top of, into a Docker container. And that gets installed to the system. And then on top of that, we have our /etc. We can change, some system settings. We have our home directory. And then we have Flatpaks, which are sandboxed apps. There's a Flatpak app store called FlatHub. We use Homebrew, which is the most popular CLI app getter management thing for macOS. It's also available for Linux, but Linux people seem to not like it because it doesn't install it to the system, so they feel like that's weird. But we think that's great because it doesn't break your system. Somebody just installing some cool new CLI tool that breaks everything, or their 5th version of Python, and everything gets confused. You just delete your entire Homebrew folder and then start again. And you don't need to reinstall your entire computer. And there's another set of tools like DistroBox, DevPod, and Dev Containers, which run Podman or Docker containers with the specific applications that you need. So you can just run, let's say the package you want just runs on Debian. Well, you just run a Debian container and then run PyTorch or Python or Node or, whatever the application that you find on the internet is. Dev Containers is a cool thing. It works with NeoVim or in VS Code, and you just define the container that you want as part of your project, part of the Git repo. So any developer working on that project can just spin up that dev container and have the same build environment, the same tooling. And so it's great if you want to be working on something and then share it with other people who want to get on the ground running right away. You don't have to start setting up all kinds of NPM packages or Python packages. You just get a container that's going to have things pretty much set up for them. And so how it works is when you're on the Bootsy image, when you get an update, you get this second image file that comes down, and it's there waiting, staged. And so when you update, it's just sitting there on your file system, and then when you restart the computer, you boot into that new file system with all your Flatpaks, Brew, CLI tools, DistroBox, your home directory, everything. And if there's some issue, some kind of kernel regression or some driver issue, you can just roll back to the previous image. It just shows up in your bootloader. Another cool thing is that you can actually switch images. So if you're on Bluefin and you want to switch to the gaming distro Bazzite, you just run bootc switch and then put in the container URI. And then it will download that container image and then stage it on the next boot, restart the computer, and then now you're running on Bazzite. Bazzite is actually a pretty popular project. It started a little over a year and a half ago. It's part of the same family of images as Bluefin, and it's built on this bootc idea of an immutable image where somebody else curates your Linux experience for you. And it's targeting gaming, and specifically all these like gaming handhelds like the Steam Deck and all the lookalikes. And so what it does is, it adds all of the features that you need, the thumbsticks and the buttons and the RGB lighting, all that stuff that gamers like. I mean, I'm not a gamer, so I don't really know. This has been taking off like crazy. I think there's about 20 to 30,000 users of Bazzite these days. All the, gaming YouTube people are starting to catch on to Linux, gaming on Linux, and Bazelite's the go-to distribution for that. And it's built on bootc, and it makes it very beginner friendly, and then even more advanced users who are using it can make a contribution very easily because it's all on GitHub and they just submit a PR. And if it's good, then it gets added in. So I don't think it's actually that frustrating if you're an expert user and you run into something you don't like, you can just, get it fixed. But, there's always a category for people who want that control. And in that case, you can actually build your own custom bootc image. So the newest addition is this Bluefin LTS that's built on CentOS. It has a much longer support cycle than Fedora's 1 year. It has 3 years of support. And so I've been working on that for the last 9 months. That's kind of my main project. And yeah, so if I were to tell anybody to just use Linux, I would tell them to use Bluefin LTS installed on your computer. You won't be sad. If you have any issues, you can reach out to me on our Discord, Universal Blue Discord. Yeah, we'll get it fixed. You can check out the website. It's at projectbluefin.io. You can download an image ISO and then put it on a flash drive. Any information you need, we have really good documentation. LTS is this new image. You can get it either, if you have a NVIDIA card, you can get the NVIDIA drivers. You can stay on the long-term support kernel so you won't get, any surprises. Download this image, put on a flash drive using a media writer, plug the flash drive in, and you might have to hit some combination of buttons to boot from flash drive, and then you can install it to your computer. Another note to add is Windows 10 is ending support next month. So I would be doing a disservice to not tell you about this. October 14th is the end of Windows 10. So anybody who has a computer that's, more than 8 years old, it won't support Windows 11. Microsoft really wants you to get rid of it. You're going to start getting a bunch of warnings. And so now is a great time to just switch to Linux, where it'll work on your computer even if it's 15 years old. And so that's where my side project comes in. Red Hat, with their long-term support release, decided to target computers that are from 2013 or newer and drop support from older ones. And so I've created this that's based on Alma Linux. So if you have a computer that's around 2013, 2014, you can use this x86 64 v2 image and it'll work on your computer. But for everybody else, you can just use the regular one or use the Bluefin. And it runs about 3 to 5% faster because it dropped support for these older instruction sets for the older version of x86. Yeah, and if any of you, have any questions, you can hit me up. Here's my website, Riley, spelled like Baraley.asia. You can send me an email. You can find me on LinkedIn. Here's my GitHub. You can send me a message on Matrix. Any of that. Great. It was great talking to you all, and I hope to see some of you in person someday.